Now don't forget to save it. And finally, we have the population and the water per capita. Now we're going to estimate the future water demand. Go to this projected water demand. So let's estimate the population with the linear regression equation that we have used before. So here, instead of the year, I'm going to select this. Okay. So it's 939.82 times the year minus 183.7306.8. Okay. So we have estimated the population. Now, here for the water use per capita, we're going to use the value that we estimated before, which is 120. So you can just type equal, then go back here to water use per capita, and select this value that we thought in 2010, and then click enter. And then here in the water use per capita, we're just basically going to use in liters per day this times the conversion factor. So we are using about 454 liters per day per person. Now let's estimate how much water we use. What is the water demand since 1970 up to 2050? So it's going to be, if this value, which is the population times the water use per capita. So now I'm going to click here F4, and you're going to see that this dollar sign starts appearing. So every time that I click F4, in this case appears 2, then just 1, and then just the other one. What does this mean? The dollar sign fixes the value in a cell, fix the cell. So in this case, if what it's saying is that it's going to be fixed C, which is the column, and then 3, which is the row. If this only has one sign, it will only fix, in this case, the row, but not the column. Or in this case, it will fix the row, the column, but not the row. So let's see if when I do this, and then I copy all of this, you can see that it's multiplying the population times the water use per capita. This value is moving vertically. This, because we fixed it with the $2 signs, is just staying there. Okay, so now we have estimated the water demand in gallons. Oh, and this is, okay, so this is the population times the water use per capita, the gallons per day per person. And we need to multiply this, so this is per day. We need to multiply it because we want to obtain the gallons per year times 365, which are 365 days. Okay, so now we have that value. And this is in gallons. We want to convert it now into acre feet, so it will be this value divided by the conversion factor, which is 325.851. And this has to be divided. So this is the projected water demand if, well, this is the projected population, and considering this water use per capita, this is the projected water demand for the city of Watsonville, considering a linear increase in the population. Now, let's think in a scenario that actually let's plot these values in a chart and see how do they look like. Again, right click, select data, and then here we select the years. Here, as the name, we're going to call it this only water demand, or let's call it current trend. Okay, and then we're going to plan for a scenario that actually will use the same amount of water before 2010, but it will only use, instead of 120, we're going to reduce it to 102 gallons per day. So a reduction of 15%. So for these years, we're going to use exactly the same water demand for this scenario. And then for these years, we're going to use population. Instead of using 120, we're going to use 102 gallons per day, and then times the 365 days in a year. In this case, in order to obtain this volume in acre-feet per year, we're just going to this volume divided by the conversion factor, which is 325 8 851. Once we have done this, let's just also plot this data. Okay, so here we use just this, and then for here we're going to use this one. Okay. Don't forget to hit Control to save it. Then once you're here, we're just gonna, instead of doing this, we're gonna select this as a line, and then I'm going to change this line color to black, and the line style as this dash. So now it actually looks a little bit more similar like the one that I'm asking here. Okay, so to be turned in, what I want is to plot both of these water scenarios. Okay, I want you to submit the plot, this plot of the both water demand scenarios, and then to elaborate that this policy produced, I mean, I arbitrarily select 15%. What action will you propose to actually achieve this 50% reduction? Less consumptive toilets or harvesting water. What would you do to achieve this 15%? Okay, this is it for this first exercise. I hope you enjoy it. See you.